Welcome. This video about using trig ratios, and this is the highly proficient level. So it's asked us to identify the trig ratios if the sign of x, capital X here, is equal to 5 over 13. And so I'm going to say we don't have a triangle, we don't have anything drawn, so we're going to just draw a random right triangle, make sure that it's identifiable as a right triangle. So try your best to draw one of those as a 90-degree angle. We're going to call that one, let's call this one Z. And then we're just going to call this one X. If you want to put it up here, it does not matter. It's fine, but I'm going to put it down here. This is X. Then we'll call this one capital Y. That usually means lowercase x is here, lowercase y is here, and lowercase z is here. But we're not going to worry about that too much right now. We do want to label this opposite the right angle is our hypotenuse. And since we're talking about x here, and the sign here is of x, I'm going to put a little theta there just to help us remind us how to label this thing. So this over here is the opposite. If you point away from that angle, it points to the opposite leg. And then the other one that we have that we need to talk about is the adjacent. So this is the adjacent leg. And because we're dealing with trigonometry, we're going to use that mnemonic that we know, sol, ka, toa. And the sign is sol. So we're going to say that's O over H. That'd be O over H. And it even helps to write it right over here. O over H. O is 5. So I'm going to put this side length is 5. My hypotenuse is 13. So this is 13. What I don't know is what's my adjacent side length. And for that, we're going to use the Pythagorean theorem. So I'm going to go over here and say, I don't know, we call it lowercase y if you want, lowercase y. So it's opposite. So I'm going to call this y squared plus 5 squared. Remember, those are the two legs. 5 squared plus y squared is equal to 13 squared, the hypotenuse squared. And that gives us here y squared plus, this is 25, is equal to 13 squared, which was 169. And then if I take and subtract 25 from both sides, that gives us, it's 169 minus 25 would be 144, I think. And then you take the square root of both sides, square root here and square root here, y then is equal to 12. And so I'm going to label that. I'm going to erase my y here and just put 12 here instead. Now I can do the ratios. We already got sine. Oops. Put those back. So cosine, let's use a different color for cosine. That would be ka. And that's A over H. So let's see here. A over H would be 12 over 13. 13 is prime and 12 is not a multiple of 13, so we can't simplify it. That would be our simplified ratio. You want to make sure that you're simplified if you can. The cotangent is the opposite of the tangent. Toa. Not the opposite. It's the reciprocal. Sorry, the reciprocal of the tangent. And since the tangent is O over A, that would be O over A. That's 5 over 12. Let's just write that over here to the side here. So the tangent of x would be 5 over 12, right? Opposite over the adjacent. But the cotangent then is the reciprocal of that. And so it would just be swapped. And so the cotangent is 12/5. And then we're asked about the cosecant. Now, what you recall, we go, I'm just going to use the abbreviation here. The sine goes with the cosecant. The cosine goes with the secant. And the tangent goes with the cotangent. Cotangent. And so just using, especially for these top up here, the tangent, the cotangent, for me, they're easier just because I know that COT stands for cotangent, so it just goes with the tangent. But the secant and the cosecant, I want to try to place the S with the S and the C with the C, but no. It's sine with cosecant and cosine with secant. So since we're dealing with the cosecant and we were given the sine, we're just going to swap those. It's going to be 13 over 5. And those would be our final answers. Ok, ahora en español. Dice, identifica las razones trigonométricas, pero no nos hicieron ningún triángulo. El triángulo dibujamos nosotros, pero el triángulo, hay que asegurarse de que es un triángulo rectángulo. Ponemos los vértices Z normal, hay que fijarse de que tiene X, y tiene X, y tiene X, está hablando del ángulo X, entonces hay que identificar que X está en uno de los ángulos agudos. Y podrías haber puesto donde tengo el Y aquí, podrías cambiarlo, no importa, pero yo lo he puesto aquí abajo, entonces vamos a dejarlo ahí. Y es el otro. Entonces, ponemos las etiquetas sobre esto opuesto es el que está al otro lado de donde está la variable, el ángulo. Y la hipotenusa es el lado opuesto. Entonces, ese es la hipotenusa. Y eso, opuesto del ángulo rectángulo. Y el adyacente es al costado de donde está el ángulo. Entonces, este es opuesto, está al costado de donde está el mismo ángulo. Ahora, no sabemos, esto, lo único que sabíamos es que teníamos el sine. El sine es so, así, so, y ese es O, a dibujarlo otra vez, O sobre H. O entonces es 5, el opuesto, y H es 13. De ahí entonces podemos usar el teorema de Pitágoras, mostrando de que así que y cuadrado más 5 cuadrado es igual a 13 cuadrado. Y cuadrado es, más 25 es igual a 169. Se resta 25 de ambos lados, da 144. Y cuadrado es igual a 144. Se toma la raíz cuadrado de ambos lados y y entonces es igual a 12. Eso lo ponemos. Y de ahí entonces podemos hacer las razones trigonométricas. El cotangent es el opuesto del tangent. Así. Entonces lo invertimos nomás. 12 que estaba abajo va arriba, 5 que estaba arriba va abajo, y ese es el cotangent. El cosecant es el opuesto. El cosecant es el opuesto del sine. Y por opuesto no está mal dicho, no es el opuesto, es recíproco. Entonces, si el sine es 5 sobre 13, el cosecant es el 13 sobre 5. Bueno, sigan adelante. Si se puede, si se puede.